Action. Good morning or afternoon to everybody, depending on where you are. Thank you for joining us for this webinar. My name's Dave Harvey, and together with Dan Spencer, we'll be presenting the webinar today. Our colleague Michael Waite is also on the line, though he's in a different city to Dan and I. Michael won't be presenting, but he may well join in answering questions at the end. Just a couple of quick points to start. I hope everyone out there understands us through our Australian accents and the fact that it's rather early in Australia, so our voices might be a tiny bit croaky. We will try to speak as clearly as we possibly can. You'll also notice throughout we have Australian English spelling in the slides. Apologies if it looks a little strange to you, but hopefully everyone will be okay with it. One more thing that's worth highlighting while we're on this slide is our website address, www.concepts.aero. That's a really good first stop if you want more information about anything you hear on the webinar today, after the questions at the end, of course. This website has a comprehensive news page, for example, which is quite a good place to see what's been happening at the company. The first thing I'll talk a little bit about is the company we work for, Aerospace Concepts. Aerospace Concepts is a systems engineering consulting company, and we do that as well as providing other related technical and management services. We operate in Australia, but we're also involved in various projects overseas. We have the three main areas we work in, shown on the slide there: model-based system engineering, MBSE, and capability development, and that's the team I lead; flight safety analysis, aerospace modelling and simulation, and engineering management system development. We have a team of approximately 20 technical professionals within the company. We tend to focus on defence and aerospace domains, as mentioned there, but we do leverage these into any other domains involving complex system engineering, anything to do with complex socio-technical systems, people and systems together. You also note we have an ecosystem of specialists in other related areas, and they help complement the central team, come in for targeted help and advice, and help us work in some broader areas, as you see on the slide there. I'll now hand over to Dan to talk a little bit about what we'll be covering in the webinar today.
Thanks, Dave. So while preparing this presentation, we've assumed some understanding of the concepts of model-based systems engineering, or MBSE as I'll refer to it from now, and the use of CORE as an MBSE tool. We've also assumed some understanding of the Department of Defence Architectural Framework, or DODAF, and how to use the core schemas for DODAF. So both of these concepts are covered by the previous two Vitec webinars that are available on the Vitec website. But what we've actually tried to assume as little as possible with regard to these things, and we want this presentation to make sense on its own, so please stick with us, and hopefully you'll get something out of it. So our aim today is to show some of how we as an engineering consultancy operate, some examples of what we do in the model-based systems engineering area, and in particular with relation to capability development projects. We also aim to show how CORE enables and enhances our systems engineering work, and some examples of how we use CORE as well. So the context we're talking within is the Australian defence environment, which is where our primary client lives. But the presentation aligns also with general defence capability development, defence projects, and requirements analysis and systems engineering in other industries and sectors as well. So our aim overall is to show some systems engineering concepts and how we apply CORE as a systems engineering tool to facilitate this. So an outline for our presentation today. The webinar will cover firstly how we are developing an overarching MBSE program which aims to produce effective and repeatable approach to systems engineering, using CORE as one of the key enablers for this. Our aim also is to roll this out across many projects for capability development over a long period of time. So after I've spoken about the MBSE program, Dave will be taking over to talk about one of the key parts of this systems engineering approach that we have, which is the defined MBSE processes. These processes are to be followed in each of the capability development projects we're working on, and they define how the model-based systems engineering tools are to be used. And those are the things that really make the MBSE program repeatable. So Dave will go into the detail of one aspect of these processes as an example, which will be the operational needs analysis, or also known as the development of user requirements, and this goes through using scenarios and operational activities and operational analysis. So Dave will also present an example used in a recent paper that Aerospace Concepts presented this year. So following this, we'll go through to the detail of how we use core in two areas, and these are our approach to extensions and customizations of the core schema, and also automated generation of documents from core as views of the model. So just on this one, our approach is model-based, where the model is the source of truth. But we need a consistent approach to communicating the content to the stakeholders, and the document generation that core provides gives us this ability.
Okay, so we've been working with our main defence client to develop an approach to capability development using model-based systems engineering. We need a way that can be taken up by appropriately skilled people across the defence environment, that allows a repeatable process and repeatable outcomes of capability development efforts and projects. We aim with this program that we're developing to define good practice for an effective analysis of projects, and for improved results to systems engineering and capability development efforts in general. Core is a key enabling component of this program, and we'll cover later some detail about how we're using this tool to enable our capability development efforts. So while we're developing methods, tools, processes, and other components of the approach to systems engineering, we're also applying this to real capability projects that are happening now in the Australian defence environment. Applying this to the real projects, that's allowed us to build our methods and tools iteratively and roll back any lessons that we learned along the way back into the program so that they can be reused at a later stage. We call this approach, colloquially, we call it building the plane while in the air, and it's focused our efforts to the development of our tools, for example the core scripts, to what is actually important for these ongoing projects. Also, it's allowed us to focus on what works for running multiple simultaneous projects at once, and rolling this information back into the program also includes the production of libraries of generic content and guidance for future projects. So in addition to using this approach on current projects, we're also using our approach for in-depth analysis to actually analyse the MBSE program itself. Colloquial term for this one we use is practicing what we preach. So we're currently running, as part of this, a complete requirements analysis of our systems engineering approach, including modelling this in core, and later on we'll actually go through some results of this analysis, such as the defined processes that we've gone through and how they've ended up as functions in the core model. So I'll just go through how the MBSE program is approached across the project lifecycle. We aim to cover across the entire project lifecycle, from needs through to needs analysis all the way through to disposal of the products. So across the top, the capability lifecycle that we've defined here is got the needs phase, the requirements phase, acquisition phase, in-service phase, and then finally disposal phase. As we go through and develop each stage of the MBSE process and MBSE program, we're actually defining each of these further and further. So the needs is really analysing what the user needs and the operational reasons behind that. Requirements phase goes into some detail of what is actually required of a system, and so on. So at this point, we've concentrated our efforts in the requirement stage, and this slide is showing an example of some of the drilling down of the requirements phase right down to where we produce some of the required views and documents that our clients need. So what we have here is we want to have this core model propagating through each of the phases of the life cycle, and we also have many models across multiple projects that'll be produced at the same time or in parallel with each other. So one of the key challenges we need to address at the moment is actually how we model the interactions between these various projects that have different timelines, different needs, and different interactions between the interfaces in the projects and general interactions between them. Okay, so what I'm going to show you here is a very basic and high-level approach that can be assumed to be taken for a capability development project. We begin with guidance, which is provided by subject matter experts and defence and client environments. This includes operational guidance, such as previous capability work that's been done on the project as well. With this guidance in the model, we then perform an operational analysis as the first step. We define the organisational architecture of the project and develop scenarios to analyse the operational needs for this for the project. Once these scenarios have been defined, we drill down into operational activities and the performers of these operational activities as we go through it. The aim of the operational analysis is to properly elicit user needs from the users, and then after that we compare these operational needs to what is actually out in the field in existing systems. So it compares the existing approach to what is actually needed. The approach we take to do this is to define first the functionality of the existing system and analyse how well this functionality meets the user needs defined in operational analysis. Hopefully this will result in a requirements gap which will justify the need for the project. So there should be some gap between the user needs and the existing system. So following this, we go through and develop system requirements based on the operational analysis and the gap shown in the existing system. So to do this, we model the functionality of the future system that's required in a way that's required to meet the user requirements, and we model the architecture of the future system based on these functionality. Based on this functionality to provide the expected result, and system requirements are drawn out of these functions and components that are defined here. So I've previously mentioned that we're running an in-depth analysis of our MBSE approach. So how have we applied this approach to developing our MBSE program? Well, what we've done here is some of the examples. So we've started off with some guidance which is provided by the prescribed capability development processes that our clients have. There's obviously a lot of work gone into what is needed for capability development over many decades. So we have a lot of guidance there of what needs to be done. But we actually need to go through and develop, and work out the way to actually approach this in our program. So we've gone through an operational analysis that has produced the user needs for the MBSE system based on this guidance, and we've compared this to the existing document-based capability development that exists out in the field and in a lot of areas where the documents are the source of truth, and it's very difficult to get the traceability through the various documents and accuracy across multiple documents that are required. So this has ended up producing requirements for a central tool being core, skilled people and systems engineers that are required to run this capability definition projects, and some defined processes, a project model, and a support system. So I'll hand over now to Dave to take through the detail of one of these required products, which is the defined processes to be followed.
As Dan has neatly introduced, the underlying process is key to our application of MBSE. It's a major requirement of our approach, and one of the reasons why is that the central tenets of what we're trying to do are structure and rigor. And since we're looking to roll this out institutionally, we need a repeatable, structured approach. In that case, we have a need for an explicit process rather than dealing with this approach implicitly via the culture in a small team, since when we expand the team or expand who's going to use the product. So MBSE process has to cover the activities for various users across the system lifecycle. Also prescribe methods for users, including system engineers and project teams to follow. And that's one of the points I should make here is that our process doesn't negate the need for system engineers. It just system engineers still required. They just prescribe methods to help them do what they need to do to eventually produce the system. These processes that we described are modelled actually in core. And over the next few slides, we'll show you an example of part of our process in core and run through a simple application of this process. Okay, so this slide shows a simple enhanced functional flow block diagram of our develop model operational activity. Some of the major features to note on this slide are the iterations and parallelism inherent in the process. So you can see around the outside there is a loop, and that describes the iterations that are taken, and in that loop is a two-branch AND. On the bottom branch of that there's a loop indicating that we are continually incorporating project risks and issues into the model, because we do take in project risks and issues in the model, and also able to report on them and link them to the model of and about the system. On the top branch of the AND there we have the main feature of the diagram, which is the 5-branch AND. And this AND has the perform operational analysis activity, also analyze and model existing capability system, define system solutions, and also be quite familiar with the stuff that Dan was just going through, perform supporting analyses, studies and reporting, and also develop the test concept, how you're going to test what you produce and see that it's what you want. So these are in an AND branch, indicating that you can do any of them at one time, and then after you have completed one of them, so say you go through and do some operational analysis, you then complete that activity, move through to X0176, as it's nicely named there, review knowledge model. At that point, you can then decide that you have done enough work on the model, it's at a satisfactory level, and exit the loop, but much more likely you would decide that more work needs to be done, and you can continue analysis. So that you then go back to the 5-branch and do some work in one of the other activities. This is analogous to the Vitek onion model, where you populate the model in the 4 domains: requirements, functional behavior, architecture, synthesis, design, validation and verification, and then increase in detail or granularity as you progress by peeling each layer of the onion. So each of these iterations increases the specificity, removes unknowns, and resolves ambiguity. And there's plenty of material available on the Vitek onion model from Vitek's website. I'm sure you can find that if you go over there. So this is very similar to what we do. As you can see, you'd go through and perform some analysis or some of these some level of detail for each of these operational activities, and then you have the complete model, and then you can look at the outputs of that model and then target where you wish to focus your effort for future development of the model. So the focus of effort for on each of these domains or each of these activities is likely to change through the development lifecycle that Dan just talked about. So for example, on the first iteration, the focus might be more on the operational analysis, and you might just touch on broad system solution concepts. The second iteration, maybe there may well be a further focus on the system concept development, so there'd be this development could be targeted, as I was talking about before, from examination of the total model and output from the first iteration. And then a third iteration may well go down to more of a detailed system design, and that design inherently through the model-based approach is linked back to the operational analysis that you performed in the previous iterations. We have had success in our previous work using this approach, and in some of our projects we're up to the third or indeed fourth iteration for detail and getting into the detailed design for some of these projects. This decomposition shows detail in the perform operational analysis activity, and I'm not going to spend the time going through this one in detail, but we'll just bring it up to show that there is something at the levels below. There is more detail, and in those lower levels there's also that same iteration and parallelism. You can see again the loop with the multi-and branch, and then the review of whether you think you've gone to a satisfactory level of model development or whether you wish to continue operational analysis. And that's another point where the systems engineer very much comes to the fore, because determining determining if you're at a level where you think that the model is satisfactory is very much a judgment call, and that judgment it's easier to make as you go forward and have more experience as a system engineer. Yeah, so just moving on to the next slide there. So we'll look at the simplified example. So we have an example here of a fancy restaurant, and we're going to work through a number of the operational activities in the perform operational analysis activity from our process from the previous slides. This is the fine dining fancy restaurant example developed for a recent conference paper written by our colleagues Michael Waite and Paul Logan, and presented at the SETI conference this year, Australian System Engineering Conference. So the basic scenario for this example is where a diner enters, is greeted and seated, orders a meal, eats a meal, asks for a bill, pays the bill. And that's the success thread of using a fancy restaurant. I'm sure everyone has an understanding of how a restaurant works. This slide shows the system context boundary, and basically outlines the system of interest and puts it in context showing who is involved. So you've got the diner, the waiter, the chef, the suppliers, and this is the part of the process that we described previously in the was represented by our identify context, system boundary, and organizational architecture, operational nodes, operational activities that I showed you on the previous slides. So to the next slide, we can see this slide outlines the scenario and operational activity model for our simple example. The process is described by the develop scenarios and vignettes and develop operational activity models, operational activities that we had in our MBSE process from the previous slides. As stated, the scenario should be as small as possible, but needs to span the full functionality and maximum performance requirements of the capability system from the end user's perspective. And this is a quote from the Australian Defence Capability Definition Documents Guide, but the message contained in this statement is universal across scenario-based needs analysis worldwide. If you're interested in that document, we can certainly point you to where you can find it if you contact us. So basically, we have on this diagram here the success thread that I was talking about before. So if we look at activity 1, the diner enters. The diner then is greeted and seated by someone from the service op node. The diner orders their meal. The service node takes the order, then gives that order to the kitchen. The kitchen accepts the order and prepares the meal. That prepared meal is collected and served by the service node. The diner accepts and eats the meal, and then the service node prepares the bill. The diner accepts the bill and then decides whether to pay cash or pay by credit card. And that's the OR branch up there. And that payment is accepted, processed by the cashier operational node. So this is the success thread that I was talking about earlier in a bit more detail with the operational activities and split into the various nodes. Once you've described this behavior of the users when they interact with the system, you can then walk through this with the user representatives and develop the operational needs. And this is the whole central theme of scenario-based needs analysis. So you can walk through the activity model and ask at each activity, what need does the user have when acting in a role whilst undertaking an activity in a scenario? One simple example of walking through the operational activity model to obtain the user needs comes in examining the operational activity 2, orders meal. So we've got it here. What need does the customer, who's the user, have when acting as a diner, that's the role, whilst ordering a meal, the activity, in a fancy restaurant, and that's our scenario. So to order a meal, the diner would need to have some way of knowing what the restaurant is capable of preparing for their dinner. So a user needs statement could read, the diner needs to be informed of menu items. Another simple example from this, our example here on the slides is activity 8, take order. So if we walk through that one, we have what need does the waiter, who's the user in this case, the service node, have when acting in the service role whilst taking an order, that's the activity, in a fancy restaurant, that's our scenario. So an associated needs statement could be the waiter needs to receive and record specific information on each diner's order. So basically you can continue walking through the model and continue this process until the stakeholders are satisfied that a sufficient set of needs has been captured that relate to the activities that they do whilst interacting with the system. So this is where it comes in. It's a bit of a mixture of art and science to know what level of decomposition to go to in order to have a sufficient set of user needs to take you on to the next bit of the process. As I said, that's where the experienced system engineer comes in. None of our processes do away with the need for a system engineer, it just structures and guides their approach. Alright, so in the past few minutes we've gone through an example of the process we've put in place to guide the implementation of MBSE. These processes are but one part of the MBSE solution. This solution also includes core models, scripts, people and a support system. The defined processes help system engineers, analysts and project staff develop capability in a structured and repeatable manner. So we've gone through one example showing operational analysis scenario development. There are very similar examples for the other domains, the system and requirements analysis. We just didn't have time to go into them. And the basic thing we need to take away from here is that this MBSE process that we put in place allows us to sort of institutionalize our approach for a wider rollout by providing this underlying process explaining what you need to do and when.
Thank you, Dave. I'm going to take you through now our approach to extending the delivered core schemas and customizations that we make to this. Our current models in core are based on the core DODAF 1.5 schema, which closely correlates to the Australian Defence Architecture, with most views that are available for this in this schema being either the same or very close to the current Australian standards. We expect a new version of the Australian architecture to be released soon, which could be it should be very similar to the DODAF 2.0 schema, and at that stage we expect to migrate to the new DODAF 2.0 schema in Core 7. In the meantime, our particular environment has on occasion required that we extend the schema to new classes, new relationships and new attributes on those classes. But the thing to remember here is that we're always careful to only customize where we find it absolutely necessary after weighing up, for example, the effort in maintenance of a more complex model, and communicating the non-standard schema around the user environment of core. And we weigh this up against communicating the model in line with existing client terminology and defence terminology in our environment, and the complexity of producing consistent document generation scripts. So in this way, I guess it can be a lot simpler to model in our own customised way, but we really need to trade that off against I guess the maintenance and the communication across the core user environment as well. That's one example of the trade-offs. But a more detailed example of how we need to store is how we need to store the information in a consistent way for the scripts to be able to make sense of the model. And one alternative to a new attribute or class can sometimes be to use the category class, which is quite a handy tool within core. But what we've found is that overuse of the category class can both confuse the modeler and really confuse and complicate the scripts by increasing the complexity of how many different predefined categories are required. So it's not a case of one thing fixing all your problems. There's always trade-offs between and things that need to be looked at to define whether or not the schema should be extended or we should go with some of the tools that we have available. So just take through one example of where we've actually found a need for extending the core schema. And this is an example that we've come up with, and I'm not saying that our approach is necessarily the only approach or the correct approach even. It's just how we've actually chosen to attack this issue. So when we're comparing the user needs to the existing operational system, we aim to clearly show the capability gap between those two things. So the process is that after we've run the operational analysis and modelled the existing system architecture and the functionality of this architecture, we're struck with the question of how do we define how well these functions address the user needs. So what we have there is on the slide is some of the functions that we've created for a particular project, and how do we map these to the user needs that we've created in the operational analysis. As I said, we'll show you what we came up with, and it's not the only way, and it might not even be the best way. So using the DODAF schema, we already have a relationship of functions to requirements class, and this relationship is the basis of relationship. But this is used to define system requirements becoming the basis of future system functions. And there's no way to identify the difference of this if we were to use the same relationship to identify the difference between these future system functions and the existing system functions, I guess. And anyway, the existing system functionality was not based on the user needs analysed, so the based on relationship isn't really really appropriate for the situation. The result is that we've defined a new relationship, which is addresses, with the addressed by being the opposite term, so we have this addressed by relationship between the operational needs and the existing system functions. But the question that we still have is how well the operational needs address the existing functions. And so we've had the subject matter experts come in and define how well these operational needs are addressed with the existing system. And so what we've ended up with is added a attribute onto the relationship of addressed by to show the satisfaction, and we've called this the satisfaction attribute. So this relationship is used to show a view that's shown here on the page in the format with enumerated satisfaction ratings shown in the right column there, which are the colourful satisfies, does not satisfy, and partially satisfies, some of the enumerations that we've defined for the satisfaction criteria on the addressed by relationship. And on this view that we produce out of the model, we've included the operational need and measures of effectiveness and the existing system functionality and measures of performance that address those needs to various levels of satisfaction. So in summary, on schema extensions, it's used from time to time to tailor the schema to meet the enterprise needs. But the extensions to the schema we've made judiciously, and we have many discussions about these within our team, and always justify to manage the complexity of the core models. Also, as schema changes are made, we also have to make changes to the core scripts that are used to produce the documentation and views that we have of the model, which I guess leads into the next point of how we produce documents in core. So our approach and philosophy to systems engineering is model-based, where the model is the source of truth for capability development data. However, for our clients, the documents are the way of conveying information, and this includes the steps that are required for contracts, for going out to tender and things like that. But also used for decision points along the process where senior managers are needed to sign off on various documents. So the views and documents are a very key way of conveying the information. Also, the documents refer to each other, and they need to be consistent with each other, so a change in one document should be reflected in another, and in that way the model-based source of truth is quite important. So given all of this, the automated document generation is an important requirement of the MBSE tool, and Core has provided the ability for us to do this, and we actually go and produce our capability documents with minimal manual post-processing now, and all of the business rules in the Core scripts. So this slide covers some of the standard Core functionality with respect to formal document generation. And within the Core model, we have a model of the document, and this shows some of the relationships between some of the document classes. So the document containing sections, and the document being formatted by document format, and the sections being processed by report scripts. So we'll have many documents in a single model, all used for a different document purpose, showing operational concepts and function specifications and performance, and so on. So we have an example of the classes here. We have a document format which defines some specifics of how a document is to be output. And some of the sections here, we relate those to report scripts, and they define the specifics of processing for various sections in the document. And the section report script relationship means that the sections can easily be added to or removed from a specific document. And if point on this, if we have no report script defined, then a simple generic section is output based on the section element's contents, such as a title and description, and maybe some attached figures or tables that may be in the model. So, as I mentioned before, our effort is in scripting and getting the scripting to work correctly across multiple capability development projects at once, and keeping these scripts in sync with the schema changes that we've made. So some requirements that have come from this is that configuration and change management of scripts is really essential. So not only the scripts, but the we need to configuration manage and change manage the scripts, the schema, the processes, and all of the products together of the MBSE program, so that they are kept synchronized with each other, and no unauthorized changes are made to any of the products without having a look to see how they impact on the other products of our MBSE program. So also we have a requirement for thorough testing of the scripts before release, which includes testing against a standard set of regression tests on top of the functional testing. So I'll just talk about one example of an extra thing we've done with document generation. So with many documents sitting in a single project model, there's quite a bit of complexity in how those sections that I went through in the last slide are modelled, and how those scripts relate to all the sections within the model, and there's quite a lot of complexity also in what those scripts are doing. So also with a new model, with a new project coming on board, the system engineers and modelers need to need a good starting point on where to populate the model to start producing the documents that they need, to start producing the views they need, and to really start developing their models. So what we actually have to accommodate these things is a document map model, and I'll try and explain this by saying that when we actually run the document generation scripts on this document map model, it produces a document that defines where in the model this section content has been defined. So it's useful to trace back from these produced documents back into the model, and we can see really clearly what parts of the model have been used to produce a particular piece of section content. For example, what might be appearing in a table, or just some text in some of the sections. It's also, this document map is also used to provide a template for a new or empty project. If it's a really good place to start from somewhere, and to know as a new project comes on board how we actually need to start populating this to get some of the results. So I'll take you through an example of how we've used this document map, and I'll use the same example that that I went through in the schema extension example earlier. And this is where we're comparing operational needs to existing system functionality. And what I've shown here is the actual output from our document map, having run one of our document generation scripts over the model. So here we have at the start of the text showing where this section text has come from, which is actually the section element that sits underneath the particular section of this document. And firstly, the description is output there. And I'll actually read through some of the other information that's stored in this description. And it says that this table was populated by the operational needs, which is of class requirement, which has a type of functional and origin operational, which are addressed by being a relationship, and existing system function, and function being a class. So the addressed by relationship has the attribute satisfaction, which describes that level at which the needs are addressed by the existing system functionality. So that whole description is actually included in our section description for in our document map model, and so this gets output and gives some sort of context to where this information has come from. So also we can see the attributes of the needs, MOEs or measures of effectiveness, the functions and measures of performance of actually output into this model, or into this document, should I say. So that gives the modeler some idea of where to start producing some of the information that's needed for the operational capability comparison, as an example of a section. So that's a small snapshot of some of the examples of things we do with document generation in our environment, and some of the things that we've come up against. So in summary, our aim is to roll out a repeatable and effective systems engineering approach to support the capability development efforts in our defence environment and across systems engineering in general. So one key element that underpins this is a defined set of processes. It's one of the many products of our MBSE approach. And Dave has shown earlier a scenario, operational needs analysis example, being the fancy restaurant example. So also we've gone through some of the ways in which we use core to enable this capability development processes, and how we've made additions and customizations to the schema, and what rationalization we need for that. The core document generation is a key element to communicate the views of these models to end users in a language that they expect. And we've also gone through how we use a document map to start enabling some of the document generation and linking that back into the modelling. So on behalf of Dave and myself, thank you for your time, and we'll move on to the questions now. Okay, the first question we've been given is, how flexible is the control of the formatted layout for the generated documents? Well, the layout and the content of our generated documents is limited only by what rich text format or RTF documents can actually produce, which is actually pretty much the full set of what Microsoft Word is able to do. So given that, it's really down to the ability that we have to actually generate the scripts to produce the output. So there's a lot of work that we've done to really refine the RTF outputs that we get from the core scripting. So the core scripting doesn't limit you in any way to how you're going to be outputting the documents. But the layouts that have been provided by the general core scripts are enough for your simple for a general document output that should meet most of your needs. What we've had to do in addition to what core produces out of the box is a little bit of post processing and for things such as footnotes that can't be generated on the fly because you need to know at what level these need to be done in headers and footers of the RTF documents. So the flexibility is there to be able to do whatever you want. It just sometimes needs a bit of creative scripting to be able to get around some of the really technical areas of how you might be needing to produce certain areas of the documents. But generally, yes, it's as flexible as RTF allows, which is the full extent of the Microsoft Word product. So the next question that we have is, how would you define the learning curve needed to be operative with core scripts? I guess this follows on well from the first question in that to get into really detailed areas of some parts of the core scripting can take some effort to actually get to know what you're doing there. And I guess the main issue is in how to be operative with core scripts. It depends on your background. I've come from a fairly software intensive background, and I've found that the core scripts are generally very straightforward as far as learning. There are a few tips and tricks that we have gone through. We generally do a 3-day training course before getting involved in the core scripts as such as general advanced core course that we do. So the actual scripting language being available through a graphical user interface is actually very approachable. So creating your first scripts to produce the documents based on the delivered core scripts is actually generally pretty straightforward. It's easy to see what the different constructs are and how they're actually used. It's not a language where you have to go in and type through all of the constructs and all of the commands to be able to get the thing to work. All the constructs and commands are there available for you to select through the user interface. That being said, as I said, there is some complexity in some of the really detailed core scripting, and also there can be a few issues that come across when with such an easily approachable scripting language, in that as we're trying to roll this out in a very repeatable and in a repeatable and proper manner of providing this product for our model-based systems engineering approach, we have decided that change control is a very necessary thing, and configuration management on our scripts. So we've actually started baselining all of our core scripts and making sure that we do some proper change control testing and release procedures on our scripting to make sure that the product that we're delivering is actually a quality product. And the reason I mention this is because having an approachable and quite simple to use scripting tool, it can be tempting sometimes for various people in our team to go and update those scripts on an ad hoc basis. But we've decided, as we want to be rolling this out onto many projects, that the change control and configuration management of these things is quite important to stick with.
Okay, so the question is, have you ever experimented with communication of data between core and doors, or vice versa? Thanks for the question. That's an interesting one. Members of our team have looked into this briefly in the past. They've done work looking into the best way of getting the information between core and doors, and even examining how information might come back from doors. We also continue to look at this in our current work, since the tracking of requirements in the contracting process is, in the Australian system at least, is mandated to be done indoors. So it's definitely a situation we have to deal with. We're currently investigating the best way to get data from core to doors, and even looking at how to process changes that are made in doors or suggested in doors during the contracting process, and how to get them back into core. Whether that be through a direct interface or perhaps through an intermediate format, an Excel spreadsheet, for example, that's structured in a way that both programs expect. This is still under investigation. This is one of our current streams of work. Whatever we use, the goal, it should be made clear, the goal is to maintain the core database as the source of truth for the project, and have doors just represent a snapshot in time of a subset of that database information. So the question we have is, have you developed any human factors or human system integration type requirements? If yes, do you have any suggestions for deriving these requirements from operational activities? Another interesting question. We examine human factors type requirements inherently in our process, rather than calling it out as a sort of explicit activity to do. Scenario-based needs approach that we take, but by looking at the interaction of the users with the system, actually does draw out a lot of these type of requirements and needs. Also, we tend to model the maintainers, trainers, and operators, particularly the operators, within our system, the sort of socio-technical system. So this also helps to derive some of these type of requirements.